My favorite kinds of architectures are the ones that you can actually touch. On the next This Is My Architecture, you're going to hear how mPrest helped Netafim build an IoT platform that helps you get better crop yields, reduce your water usage, and a lot of other benefits. Welcome to This Is My Architecture. I'm Matt from AWS. We're here in sunny Tel Aviv, Israel, and today we're going to talk about an interesting company, Netafim, who over 50 years ago invented drip irrigation. More specifically, Aviad from mPrest is going to tell us about an IoT platform that you built for Netafim, correct?
Yeah.
So what I like about this is they have this company that over 50 years ago created this technology, and today they're sort of reinventing it for the cloud.
Yes, actually Netafim, together with mPrest, which is a leading software company, we build an end-to-end solution from the field and to the end user to automate everything on the field, starting from collecting data from the field to operate the valves, how to transfer water, and at the end, how to recommend to the user how to irrigate and to do it automatically for him.
That's great, you know, because I spend my whole day talking about software. So it's so nice once in a while to talk about hardware that I can touch. And, you know, this isn't your normal reference architecture. We have what looks like corn with a device over there, and we have a happy farmer down here. So tell us a little bit about the solution that you built.
So at the start, we have this device here that sits on the field.
Okay.
And this is the end device, which you call RTU. Remote terminal unit. And the user connects all kinds of sensors to this unit and connect valves and sensors. And we have lots of this on the field.
Okay.
And all the devices communicate with a central unit, which we call MCU, the main control unit.
So are they, like, I imagine out in the field you don't always have like high-speed internet connectivity. How are these devices communicating with each other or with the central unit?
So these devices communicate with the MCU using LoRa,
Okay.
LoRa network. We have this small antennas here, and we have several hundreds of these in the farm. And main control unit, the MCU, communicates with the cloud using cellular or Wi-Fi or all kind of.
Whatever is available.
Yeah.
And I imagine, you know, when you're out in the field, we did a video that some of the viewers might have seen earlier. We talked about LoRa and LoRaWAN, and one of the key points is how to handle disconnections or sort of low bandwidth, et cetera. So how do you handle that? Are you buffering the messages or something?
Yeah, we are serving all the messages in the MCU. Actually, the user can use the MCU as his reference points to the fields. You have a screen and you can use it. And we buffer everything in the MCU, and when we have communication again with the cloud, we send everything back to the cloud.
Okay, so when Wi-Fi is available or cellular or whatever, you know, transport is available, you then connect. And here I see AWS IoT Core. Is that where the messages are getting sent?
Yeah, the MCUs, the field devices, says everything to the IoT Core.
Okay.
And we have several thousands of devices that can communicate with the IoT Core.
And is that using the MQTT protocol?
Yeah, using MQTT protocol. It's very secured, and all the certification process is very useful for monitoring everything.
Okay, so you have that secure, lightweight communication with MQTT, all the data flowing into AWS IoT Core. What happens next? So
next, we have several rules in the IoT that send messages to the Kinesis. We have several Kinesis streams.
So you're actually inspecting the messages using the AWS IoT rules and then redirecting them to different streams?
Yeah, according to the topic or the content of the message, we send them to several streams.
So what would be an example? Do these messages or different types of messages correspond to different types of devices out in the field? Or?
Yeah, for example, settings, which valves we have, and this kind of information needs one kind of treatment. And for example, live data.
Yeah.
If I'm irrigating right now, or if I have some kind of alerts or something like that, need some kind of other treatment.
We need a real-time action.
Yeah, it needs to be much faster, so we have more shards on it. And we have the administrative data, which logs, and which we can handle it in a separate way.
Got it. So the frequency and message type requires different actions, different number of shards.
Yeah, we didn't want one data to interfere with another.
That makes sense. So you have multiple Kinesis streams, and then I see you have Lambda here. Are you sort of firing off Lambda to pick the messages off the streams?
The Lambda processes the messages from the Kinesis, and every kind of message needs different kind of treatment.
Okay.
For example, logs on images and all kind of more heavy data go straight to S3, and where we save and archive it, and we can analyze it later on with Elastic Cache or Elasticsearch and all kind of things.
Yeah.
And all kinds of measurements, the sensors data. You can have several hundreds of sensors per farm saved in big data, which we are using Redshift, which is great. We can query, we can query it like it's a real RDS engine. It's very easy to use.
Yeah, analytics is such an important part of sort of agriculture these days. Yeah, it's nice to see the Redshift data warehouse there. So you also have RDS and ElastiCache. What are these used for?
So RDS is, here we save the settings of the farm, which valves I have, which irrigation programs I have, and the accounting. And what is interesting about the RDS, which is it's a mirror of the database that we have on the field.
Okay.
We are using MariaDB that sits on the edge device and on the cloud.
Okay, but that's interesting. So RDS from MariaDB up in the cloud, but also actually on the MCU on the farm.
Yeah.
Okay.
Yeah, we are using some kind of replica that we developed, and this is a multi-tenant database. We have a huge database for all the clients.
So that's actually an interesting point. So each individual farm obviously is an individual customer, but then this is a multi-tenant sort of SaaS platform, correct?
Yeah.
Okay, great. And then finally, you have ElastiCache over here. What is that used for?
The ElastiCache is using more for real-time data. For example, if I'm irrigating or if we have alerts or something like that, everything's saved in the ElastiCache and deletes when it's not relevant anymore, and the data is replaced by newer data every several seconds if the user is logging into the system.
So I know earlier we talked about a situation where there could be a disconnection, but when it is connected and when you have, for example, this happy farmer using the interface, how long does it take to process information and make this information available to the end user?
The whole process from the end device to the user, when you can see it in the website, takes about 200 milliseconds.
Oh wow, 200
all
milliseconds.
The round trip.
Yeah, not much. So you have the website running on Beanstalk down here, so web interface. I guess, is this more of a monitoring and dashboarding application, or can the user actually send commands back to the devices on the farm as well?
As well, yeah, both. The user can browse to the website, and the website uses all the data from all the sources we see here. And this is for monitoring. You can analyze the data and you can decide what to do or to say that everything it's okay. But for example, if you decide that it needs to irrigate now or to change some kind of settings, you do it in the website, and we send the command to the IoT Core platform. Send the command back to the device, and the device sends response back that's stored in the cache, and the Elastic and then Beanstalk just monitoring the results and then turn it back to the user. So
there's sort of a real-time response. You know, what I like about this architecture is I think of my own smart home, and I use smart things at my house. And I think most people associate these types of IoT architectures with light bulbs or kind of more domestic things. But what's fascinating about this is you have this connected or disconnected IoT infrastructure for irrigation, for real sort of important use cases on the farm, or I imagine you could use it for a number of other use cases as well.
Yeah, the edge device is actually a platform that can use for everything, and it holds up hundreds of devices inside it. It's not that one sensor that connects to the IoT platform. It's a gateway in the field.
Yeah, well, I love how you're using AWS IoT Core to handle your messages, Kinesis, the different data source for different types of data. That's great how you sort of tiered and organized your data like this. And then, of course, Beanstalk is tried and true for web interfaces for our nice, happy farmer down there. It's an interesting architecture. Thanks for sharing it with us.
Thank you for having me.
And thanks for watching. This is my architecture.